Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the Adams Rite, their part number 7100-310-628-00. This is an electric strike, and here it is. And that part number conspires to mean specifically this strike, and we're going to dissect the part number in a couple of moments. This strike is appropriate for use in aluminum frames. You can use it in other frames, but what makes this more appropriate for aluminum frames is the radiused corner that you see there. Generally, prepping an aluminum frame would be done with a router, and squaring corners on aluminum, of course, is not done with a hammer and chisel, so a radiused corner would be appropriate for this sort of installation. Used with Adams Rite dead latches or cylindrical latches, used in aluminum frames. Of course, the intent of an electric strike is to allow some sort of remote locking, whether it be a push button at a reception desk, or it be a keypad, or it be a remote, or it be an overhead door operator for handicap compliance that is communicating to the electric strike when a push button is hit, let's say from the interior. You can push that. The operator will get the signal. It will first communicate to the electric strike and say, please let go. And then after a minor delay, the door will begin to operate open. Lots of uses for an electric strike, certainly. There is a link below this video to a document called instructions, which are, of course, included with the unit. They're in the box, but the PDFs are here. And let's first take a look at the other link called template, which would be better called product brochure or cut sheet. On page 2 of the product brochure is how the part number is derived from Adams Rite. So this is a 7100. When you look at the 7100 in that table, what you're saying is I want a flat faceplate, versus the 7101, which would give you a radiused faceplate that you would use in the inactive of a pair of doors that have radiused door edges. Okay, the next part number, ours is 310. Just turns out that the table also has 310. The 3 means 12 volt. The 1 means DC, DC type current, 12 volt DC, which would operate as a DC sort of unit. The 1 in the part number, forgive me, the 3 is 12 volt. The 1 means continuous, but can certainly operate as an intermittent sort of strike. You don't have to have power being supplied to it continuously for this to work. It can be just upon application. The 0 in the part number means fail secure. But, let's back up. The voltages are going to be 12, 16, or 24. The current and duty can be DC continuous or intermittent. It can be AC continuous or AC intermittent. The next part, the 0 in the 310, tells us that it's fail secure, meaning that, and this is a real important part, upon loss of power, when there's no power going to it, it's locked. Okay, so the DC, the continuous power would be that you're constantly supplying power to the strike in a DC sense so that it doesn't buzz, because a AC solenoid you would hear the buzzing sound upon application of current. So you wouldn't necessarily want continuous and AC, because you'll be hearing the buzzing all of the time. And so the question is, well, how do they accomplish that? Well, when they use a AC continuous, it's a DC solenoid that they have applied a rectifier to. So you're getting this, but you can apply AC current to it, but you won't have that sort of problem. Fail secure, so that's really important. When the power is cut, it's locked. And that might be very appropriately what you want. A scenario for that would be very easily explained. You've got a 3-flat building. You've got intercoms, you've got the front gate of the building, you want to be able to buzz someone in. The pizza man gets to the front door of the building and you've gone downstairs to meet them. etc. But you want to remotely let somebody at least partially in. Or same scenario, jewelry shops in New York City seem to have the doors latched, and to be able to get in there, you're going to be buzzed in, and that would be buzzed. You would hear a buzzing if it was AC intermittent, where you hear a bzzz and then you know to pull the door. The downside of DC voltage is that you don't hear that. You can add an annunciator to a system. If you need to have DC sort of application, you can apply annunciator, but again, intermittent use only is where you're going to really have that. You don't want that buzzing all the time. The next set of part numbers will be the finish. That's very simple and straightforward. This is the 628. That is satin aluminum. Well, I should say it's clear anodized aluminum. 605 for bright brass, 612 for satin brass, 613 for oil rub bronze, 313 for a dark bronze anodized, 335 for black anodized, 625 for bright chrome, and 626 for satin chrome. After that, you can get into some lip extensions, which would basically change out this black piece that will give you a greater dimension off the jamb. Let's say you had a 2 1/4 inch thick door, and therefore the rabbet of the frame was bigger than standard. That's a scenario where you're likely going to need a lip extension, okay? Whatever the case might be. Or you might have the door inset deeper into a standard frame, but you don't want the latch bolt striking the jamb prematurely. You might need a lip extension for that, okay? The standard package is going to include, what's nice about this is that you're going to get mounting clips that you can attach this. You can prep a frame directly. Forgive me, it's going to look like this. Like this, and then like this. Forgive me, I'm blowing it. Cross section. It'd be better just to do this, I suppose. It's going to look just like this when you install it. Mounting screws, you'll have mounting screws to attach the tabs, the mounting clips or mounting tabs directly to the frame, and then the strike to the tabs itself. You're going to get some shims to accommodate jam or style extrusion thicknesses greater than the standard eighth of an inch. You're going to get 4 little pieces of chopped up aluminum with a hole through it in case you need to pad the strike out a little bit should you have a frame that is simply thicker than 0.125 inch. Okay, those can go onto the face of your tab. They'd go right here to build that out. Very common. Lots of options with these as well in terms of monitoring. You can have the strike report back the condition of the latch bolt, meaning there will be a little trigger switch inside of the keeper that when the door is closed and the latch bolt's making contact with that trigger switch, it's reporting back to a central station that says good, latched, or not. Why would you want that? Employees in a nursing home might go out a stairwell door for a smoke break. What you don't, and maybe that's per company policy, not an approved practice. How are they going to get back in without walking through the front door? Well, what they might do is keep the door ajar. It might physically prevent the door from closing all the way. That monitor switch is going to report back to someone that says, door is not latched. The other reason that makes a heck of a lot of sense, same nursing home, it sounds a bit ridiculous to say this, but you need to know the condition of the door so that grandpa doesn't leave the building. That's why you might want to know that very, very clearly. These are life safety issues, and the job of hardware is to accommodate those real human world requirements. And that monitor switch can be thought of as a way to work towards solving those types of problems. The first page of the cut sheet will give you an overview of the strike itself, and I won't beleaguer all those points because we kind of already have. The faceplate of the strike is 4 7/8 tall. That's an industry standard, 1 1/4 inch wide. The center line of the screw hole to the edge of the lip extension, you can see roughly is about 1 1/8 inches. Talks about the case opening or the case itself. Overall depth of the unit, about 1 5/8 inches. deep. The height of the case itself, 3 3/8, that makes sense. 1 inch thick. These dimensions are provided to help you make sure that you can accommodate the body of the strike back in the back side of the frame. Strike lip, we talked about that, standard, then you can get extensions, fail safe, fail secure. Fail safe is when the power is cut and the lock is unlocked. That might be appropriate in certain instances where you need a door to fail unlocked, or quite the opposite when you must have the opposite scenario be the case. A fail-safe lock could be thought of as a timeout room where the door is normally unlocked. Someone goes into the timeout room in a young adult detention type center or a school for troubled youth. Door is opened, child is put in the timeout, power is applied to lock that door down. But when the power is cut, of course, let's say in the event of an emergency, that door is unlocked and you can get out. That would be a good application for a fail-safe application. Function, we talked about that, obviously remote control. Now moving on to the link called instructions. All of the strike, on page 1, all of the strike details are there. A jam preparation is shown. That's handy. It's handy because it will show you where to drill the holes for the mounting tabs. That's 6 1/8 inch center to center. The installation instructions are shown there, detailing the installation of the mounting tabs. A couple of wire nuts are included once you connect them, and being a DC current, obviously the wires are not, there's no polarity on the wires, so that's easy. AC, of course, has polarity on the wires. DC does not.
Checking on that. Here's what I found on the web for, of course, has polarity on the wires.
Siri must have thought I said something. Page 2 goes over the fail secure, fail safe options, the available voltages. We don't need to go over that. The monitoring we talked about. In case you are running a AC, it talks about the different colored wires and what their operations do. Common or normally open, normally closed. Maximum switching current 7 amps at 250 volts. You want to be sure that you're not certainly applying far more than this can handle in an intermittent sense. Intermittent duty solenoids should not be converted to fail-safe configuration. Fail-safe units use only as continuous duty solenoids. That would make perfect sense. You might be powering that timeout room for longer than you intend, so a continuous duty solenoid would have to be applied in that scenario. Solenoid data is down below. That's very handy because it's going to give you the ohms, the amps, the watts that are required in both instantaneous or intermittent and continuous conditions. On the bottom right-hand side of the installation instruction, it talks about how to field reverse the operation of the strike, fail-safe or fail-secure. That's handy. You've got some wiring diagrams there as well. The Rite 7000 series strikes are probably the most common electric strike that you'll run into in the world. They are ubiquitous, they are predictable, they are reliable, they're dependable. They do fail because they are middle of the road strikes. They're not excessively expensive. They're not going to hold up like a $400 electric strike. But for the majority, 90% of the applications, a grade 2 strike like this is going to be absolutely perfect for your installation. And I state grade 2 because I believe it to be a standard duty commercial strike. I do not see where it's listed as a graded strike, so possibly that it's not. My experience tells me it's good for moderate use, occasional use. You'll have a gas station that you'll walk into, and a sister company of Adams Rite would be Folger Atom. You'll see a Folger Atom strike installed there where that strike is several $100s, but it is meant to run continuously all the time, or a currency exchange. something that needs to have a significantly more robust construction to deter the breakdown or the tampering or the vandalism aspect or the high volume use. But at the same time, if you've got the front door of a 3-flap and you need to just buzz your mom in when she gets there, if a $500 full Geratum is not the proper piece of hardware for that. It's hard to argue against heavier quality, but when it comes to economics, it's not the appropriate strike. Enter the 7000 series from Adams Rite. Okay, that's what that's intended for. In conclusion, there's a link below this video to the manufacturer's page where you can pull up not only all of the Adams Rite products that we sell, but a link to the manufacturer's website, as well as a link to the full product catalog, which is nice, but also a link to the parts manuals. Now, what separates Adams Rite from many other people in the world is that they publish the parts diagrams for their products. And why that's an advantage? You're going to buy this strike, and let's say in 5 years you need to replace a $10 item on it. The fact that Adams Rite publishes this data for you to be able to get your hands on and buy only that piece, like commonly a solenoid needs to be replaced because there's a power surge or a lightning strike, and the solenoid took that electricity, and now the solenoid needs to be replaced. You can replace the solenoid, not the entire strike. You can get the part number of the solenoid from the published data. That makes me appreciate and be preferential to considering Adams Rite in a lot of applications, because you can rebuild it and continue to get useful service out of the significant investment in hardware. That's the bottom line. Nice people too. Every time I send them a technical question, they always and without exception respond. So that's, that separates them from other people as well. Any questions on the Adams Rite 7100-310-628 electric strike or any other Adams Rite product, please feel free to reach out to us. And thank you.